Hi, Year 8. So we're going to do just a quick kind of look at what the Year 12s will be looking at in a few weeks, months, like November. And just, I think sometimes looking at what the seniors have to do kind of helps us figure out what we should do, how hard it's going to be, what kind of things are going to help us once we get into those exams. So this kind of thing they're not going to get rid of. So they're not going to get rid of giving you these formula sheets because there is no way you could remember all of this stuff. And it's more going to be about testing how you can use these formulas. I wouldn't say anyone can remember, but it is hard to remember things, but we don't really need people to be able to remember things. If you think of a scientist who's doing some really important work, you want them to be able to remember a certain amount of information, but you also need them to be able to apply that information and know when they can't remember and look things up. You know, there's plenty of books on the internet. You don't want, you know, a pharmacist just going, oh, I think I remember it's this, and making something up. So we've got lots of formulas in here. If you look at the video, and most of them we aren't going to zoom in a bit. There you go. That's easier. So we've got all of these ones that are about motion and energy transformation. So this is some of the stuff we're doing, but much simpler. So we'll be looking at like this potential energy, elastic potential energy. I think we're going to do this one. I think we might actually try and use this formula. It's not particularly difficult. I'll give you some hand holding. See, this is why I'm terrible at planning, because I always go, this is exciting, this is exciting. Oh, should I do this? Should I do this? The rest of it we won't look at. But look, there's energy, kinetic energy, and there's fields. Again, we won't do fields, but that's magnetic fields. And then there's this. I imagine you're doing some of this with John, Mr. Whitmer. Maybe not quite in much detail, but you'll definitely be working some of these things out when you're thinking about what you're making. And then this wave concepts at the bottom, we're going to do some of this Snell's law, and the refractive index and speed wave. We'll do these as well because, yeah, we're going to do them. So I'll be able to give you the, you know, some examples. We'll work through them, and it's just taking the numbers and identifying what the different numbers are here, here, and here, and putting them in to get answers. So why am I showing you this? Well, also I think it's kind of interesting to figure out what we've got. So our light information, some data that you might need. So, you know, these constants, it's not going to, no, I'm not going to say no one, there's always someone, but remembering these is going to be really, really, really hard with all the other stuff you have to remember. So they give them to you. And then the final bit they give you, which is useful, is they give you these prefixes and then this unit here, so you know what a ton is. You know, it's 10 to the 3 kilograms. So they give you this information. I don't particularly like it like that because of the way my brain works. So I would, if I was in the exam, I would rewrite it very quickly like this, just for my brain. And I'll quickly go through an example. I'm sure you're doing this in maths and it's not particularly difficult for you, but I will just explain. So we've got our symbols, which I just took from here. So I just went, and oh, and it also goes backwards to me. I think the biggest one should be there and the smallest one should be there. That's how my brain works. But anyway, so we've got giga, which is G, gigawatt, like Back to the Future, then mega with 10 to the 6, kilo 10 to the 3, then whatever our thing is, so our meter, our gram, our joule, our newton, whatever our unit is here. Then deci I've put in pink because it's not on here and we don't use it really, but you might see it in some of the English, if you watch an English video or an American video, sometimes they use it as well. I don't know why they use it, because I think milli to meter, like milli to there is enough, but the milli, you kind of use this all the time because millimeter. Micro, we're getting much smaller again, and it's this, can't remember the name of the symbol, but it's this kind of U with a tail. I guess I don't know what you'd call that. Yeah, I call it U with the tail, I suppose. Then nano, which is 10 to the 9, and pico, which is 10 to the minus 12. So very, very small when we get to our pico. As a chemistry teacher, I don't think we ever really use this. I imagine in physics you probably do, but we tend to go down to nano. Anything smaller than that's probably a bit too small for what we look at. Right, so I have looked up this as an example. So we've got that number, which is not just pulled out of nowhere. So we're looking at joules, so why not do my joules here? So joules, because it is, if you look at the example I gave you, if you look at it, joules is a pretty small amount. So if we look how much energy we need to do different things, it's not a lot. So we're going to use lots and lots of joules. So we're going to generally be going this way, not that way. There are other things where you might be going more down here, like when we do measurements of very, very small things like amounts of drugs, or our wavelength, our measurements around light tend to be very, very small down this way. But this way we're going to be looking at big amounts of energy. So if we're burning something, we're giving off lots and lots of energy. If we're looking at the energy on your television or your washing machine, it's going to be larger rather than smaller. So I got the figure from here. So that's how many kilojoules that I need to, that it says the average person is eating in a day. Which is kind of my first thing off the internet. I have no idea how many I'm supposed to be eating. We're in lockdown, who minds? So that's that number there in kilojoules. We could also write it as, and pick another pen. You could also write it, this one, this number here, 8.7 times 10 to the... So that's another way you could write that number there, which is easier once we get to our big numbers. So it's much easier to write this than it is to write this. And it's going to be easy as well because you're going to be using calculators, like just a normal calculator, and it can do these conversions for you. So you can just get it to get these numbers rather than having big numbers. Because if we go down this way, it's going to start getting really big. When we have to write lots and lots of numbers, it's very easy to forget a 0, and then that throws everything else off. So we're then going this way, 10 to the 6, that's 0.87. Then 10 to the 9 is going to be oh, we don't need those numbers there. 1. See, I'm already making a mistake because I'm not using a calculator. 0.87 times. Yep, that's it. Right, then when we're going this way, this is when it's going to start getting that too giant and we need to start using our scientific notation, because if we're just going this way and we've got our 8.7, 8, 7, 0, So you can see if we were then putting that back into a calculator, doing something else with it, it all starts to get really, really confusing and really, really, really long. And you might be rushing, so you might do a dot rather than a comma. And then I think it's a decimal and you think it's a decimal, and it all gets quite messy. So that's when we would just use our scientific notation here. So this one here, becomes 8.7 yeah, so that would be 8.7 times 10 to the 9 millijoules. So I'm sure you are, wondering why we would do this. I think it's just to keep it simpler for us. Think of these big numbers, and if you have to do lots and lots of these calculations. Also, if you do make a mistake, so how I made this mistake up here, if I made that in one part of my question and then used that wrong number in my next part, so part A I got that, then part B used the wrong number, I only lose the mark for part A. Part B, it's fine. I will get I'll get all my marks if I'm using it in the right way. So if I've used it and I've got like continuation of doing the right thing with the wrong number, I continue to get those right marks. So I hope that makes it a bit clearer. So you will get given a version of this for all of your physics tests and everything, and in addition to a version of this, so in a version of the equations you need, you get to take in a summary sheet. So a summary sheet is an A4 sheet with either hand or typed notes on that gives you maybe examples, diagrams, reminders to help you. And that's our physics math.